Whoa, Mr. Tran here with another video. FRQ analysis, experimental design problem. So the first part. A United States Forest Service ecologist periodically sampled plant biodiversity on Mauna Kea, Hawaii between the years 2000 and 2012 during a 12-year period of drought to determine the relative abundances of the native hardstem lovegrass versus the non-native fountain grass. Describe two characteristics of invasive plants that help them outcompete native plants. Okay, so I definitely have some key concepts here. Again, there's a short passage. The native is considered to be the hardstem lovegrass, and the non-native or invasive is the fountain grass. I need to describe two characteristics of invasive plants. So those are the key concepts there. Invasive species generally have a greater range of tolerance than native species. So what this means is that they can have higher drought tolerance while the native species need a lot of water or they would die. And then the second point that we can bring up is that invasive species are often generalist, so they can adapt to habitats that are constantly changing. And this is not true with native species. Species that live in a specific habitat, they have specific conditions in which they thrive. And last but not least, we have invasive species are generally selective species. So all of these are considered to be properties of our species. Okay, there we have it. The research findings are summarized in the graph above. We have three parts here. Let's take a look at each one. 1. Based on the data in the graph, identify the year in which abundance of native plants versus invasive plants is nearly equal. So I'm taking a look at my graph here, and I see that the year that they are nearly equal to each other is 2002. Also, we can interpret that as also near, so 2001 works as well. Number 2. Describe the change in overall plant abundance from 2000 to 2012 using the data in the graph. So this part is very specific. The prompt says to use the data from the graph. So you will not get any points if you do not mention the data in some way. So I took a look here, and again, my number seems to indicate that at around 340, and this is, we have to use very specific units. This is the number of plants, so it's 340 plants per 100 meters squared, and it decreased, this is a key word, decreased to 300 plants per 100 meters squared. So that's the complete answer. If you just put down decrease, that is not enough. You have to use data when they ask you to use data. So again, using data in the graph, you have to use the numbers. I'm highlighting the numbers. And again, the numbers. Okay. Number 3. Explain what the trend in relative abundance of native hardstem lovegrass and the invasive fountain grass over the 12-year period implies about each species' ability to withstand drought conditions. So if I were to look at the relative abundance, y'all, those are the numbers that I see plotted here. I take a look, and the square is my native grass, and it looks like it is generally decreasing. Okay, and the invasive species, triangle, is increasing. So what we can imply is that the invasive species is more drought tolerant than the native species just by looking at their abundance over the years. Okay, so again, invasive grass increased in their relative abundance while the native grass decreased. So that implies that the invasive grass can survive in drought conditions. The next part, explain how a loss of species diversity would affect the stability of an ecosystem. So we went over this at the beginning of the year. I believe this was the basis of chapter 3 in our textbook. So the more genetically diverse population is, the better it can withstand environmental stressors. So this is the key part, the first part of our answer choices. Again, these are the appropriate answers that could be used, and I'm reading off of the first one. Better can withstand environmental stressors. So a loss of biodiversity would mean that the ecosystem would be damaged during times of environmental stress. So again, key things here, ecosystems would be more likely to be damaged during times of environmental stress if we have a loss of biodiversity. So you have to mention the loss of biodiversity in some way. Remember, explain means to link and reason with what you said. So your statement about a genetically diverse population better withstands environmental stressors. You have to link it back to the loss of biodiversity would most likely cause the ecosystem to be damaged. The other answers are also appropriate. Based on the data in the graph, the Forest Service decides that a coordinated attempt should be made to remove non-native fountain grass from Mauna Kea to protect the native hardstem lovegrass, following an integrated pest management approach. So we have 3 parts here. Let's go through each one. 1. Describe the process of IPM as an environmental solution. IPM, y'all, if you guys remember from our study of agriculture, is integrated pest management, and it's used to effectively control pest species while minimizing disruption to the environment, especially limiting the introduction of chemicals into the environment. So we don't want to use a lot of pesticides here. And again, there are many methods to this. We can use physical, biological, or limited chemical methods. Number 2, the ecologists want to begin their integrated pest management program with physical control in a managed area and establish a 10-hectare plot in which they will test their efforts. Based on the data in the graph and the information provided, identify a testable scientific question that the ecologists could use to guide their physical control efforts. So the first one is super duper simple, and it's the one that I actually thought of as well, and that is, will the physical or removal of invasive fountain grass affect the relative abundance of the native hardstem lovegrass? So removing must have an effect, right? That's what my logic was headed. Remember, you must have a measurable dependent variable. So that measurable is relative abundance. Number 3, describe a reasonable research method that the ecologists could use in their physical control efforts. So this is sort of very, very similar, but very, very limited experimental design. So we want to create a good testing area. So we would want to remove both types of grasses from the test plot at the beginning of the trial and reseed the area with hardstem lovegrass to see what happens as the trials commence. So we want to clear it out, plant some of the hardstem lovegrass, and see if they actually grow. After 4 years of physical control efforts, the ecologists evaluate the abundance of each type of grass in the test plot. They discover that although there is less fountain grass in their test plot than when they began, there has not been a significant increase in native hardstem lovegrass. Assuming the ecologists wish to continue the IPM approach and continue their removal efforts on the test plot for another 4 years, explain one modification that could be made to the research method you identified above that could alter their results. So one possible way is to introduce a biological or limited chemical control to the removal regimen, and it has to be consistent with IPM. this could definitely increase the relative abundance of the native hardstem lovegrass. Hopefully this analysis of the answers help with your submitted response and help you self-grade as well. So after you view this video, go back to your submitted response and look over your answers. Have a good one.